Plate Motion Unit, Lesson 2.5, Identifying Plate Motion at a Plate Boundary. Activity 2, Interpreting Plate Boundary Evidence. Here's what your student screen looks like for this part of the lesson. Students, let's read the message. We just received new evidence from a group of scientists studying the ocean floor at the boundary between the South American plate and the African plate. The scientists told us that a mid-ocean ridge called the Mid-Atlantic Ridge is located along this plate boundary. We hope you will find this new evidence helpful as you work to determine how the South American plate and African plate moved. We eagerly await hearing your findings. Here's what your student screen looks like for this part of the lesson. We've recorded evidence about the different types of plate boundaries and their landforms on our plate boundary comparison chart. Today, we'll discuss this evidence and the new information from Dr. Moraga to identify the type of plate boundary between the South American and African plates. Students, examine your plate boundary comparison charts from the previous lesson. Let's discuss the new evidence from Dr. Moraga about the Mid-Atlantic Ridge. What can this tell us about the plate motion at the boundary between the South American plate and African plate? Students, refer to your plate boundary comparison charts to help with your analysis of the new evidence. If you have a digital partner, share your ideas. This map includes all the evidence we have about landforms, earthquakes, and volcanic activity at or near the plate boundary between the South American plate and the African plate. You'll use the evidence presented on this map to answer the Chapter 2 question: how did the South American plate and the African plate move? We know that plates move toward each other at convergent plate boundaries and away from each other at divergent plate boundaries. To answer the Chapter 2 question about how the plates moved, we first need to identify which type of plate boundary, convergent or divergent, is between the South American plate and African plate. You can refer to your charts as you evaluate the evidence about landforms, earthquakes, and volcanic activity to determine how the plates are moving in relation to each other. Let's return to our investigation question and think specifically about landforms at each of the different types of plate boundaries. What happens to the plates and the mantle at convergent plate boundaries as plates move toward each other? You may respond, one plate moves underneath the other and sinks into the mantle. When one plate moves under the other, what landform forms? You might respond, a trench. What happens to the plates and the mantle at divergent plate boundaries as plates move away from each other? You might respond, rock rises from the mantle and hardens, adding solid rock to the edges of both plates. When plates move away from each other, what landform forms? You might respond, a mid-ocean ridge. Now, you'll discuss the evidence related to the Chapter 2 question. Consider the evidence on this map and discuss the question in partners. Which type of plate boundary do you think this is? How are the plates moving in relation to each other? Understand that the data included in the map provides conclusive evidence that the plate boundary between the South American plate and African plate is a divergent plate boundary. The plates are moving away from each other, and the rock from the mantle is being added to the edges of both plates at the boundary. Which piece of evidence was most convincing in helping you determine the type of plate boundary between these two plates? Understand that the evidence is conclusive because a mid-ocean ridge is a characteristic landform that is only present at divergent plate boundaries, where rock from the mantle is added to the edges of both plates. How can we use our understanding of how the plates move at this divergent plate boundary to explain why Mesosaurus fossils that were once together are now 4,000 kilometers apart? How does the landform evidence refute or go against the claim that the plate boundary is a convergent plate boundary? Refer to the plate boundary comparison chart to review what a trench is, that a trench is a landform that is characteristic of a convergent plate boundary. Since there's no trench at this plate boundary, we can conclude that it is not a convergent plate boundary. We know from our previous investigations that at a plate boundary where the plates are moving toward each other, as one plate goes underneath the other, a large trench forms. The evidence that there is a mid-ocean ridge at this plate boundary rather than a trench refutes or goes against the claim that it is a convergent plate boundary. Mid-ocean ridges form at plate boundaries where the plates move away from each other. They do not form at convergent plate boundaries. One important aspect of a scientist's job is to analyze data. Geologists analyze all types of data, but one important type is data that shows patterns on Earth's surface. Here's what your student screen looks like for this part of the lesson. Vocabulary: analyze, to examine in detail for a purpose. Remember to look at the glossary if you need more support. You just analyze data to determine how the South American plate and African plate moved. End of activity. Be sure to complete all your student work in Amplify for this activity before moving on.